Oh, I'll try again.
No, you won't. No.
They prayed on my downfall.
All right, y'all, let's just say one quick hi, Aiden, okay? On the count of 3. 1, 2, 3. Hi, Aiden. Okay, good. Because we know that this is really for him. He needs to see the videos. He's probably going to be so happy that we talked about him, and I don't care. All right, chain rule today. It's really good. You have seen this, y equals 3x cubed. And you know how to take the derivative of this one. Okay, what would you do?
9x squared.
9x squared, right? Okay. What you don't realize what you're doing is you are actually also taking the derivative of that guy, the x. What is the derivative of x? What's the derivative of just x? 1. So you're actually attaching a chain to it, but we've never done that before because we never really had to. It's times 1. It doesn't do anything. When that x becomes a quantity that's raised to a power, any power that's not 1, so a 2, 3, 4, any quantity raised to a power, you have to take the derivative of what's inside. And that's called the chain rule. Okay? So we are going to practice this. We're going to actually be doing fairly simple ones today. And then next class, we're going to be doing a little bit harder ones. So first things I want you to write out is how to find the chain rule. To find the derivative of a parenthesis or root raised to a power. So anytime you see a parenthesis that's raised to like any power greater than 1, anything bigger than 1, you know, a 2, a 3, a 4, a 5, whatever, or a square root symbol. Okay, anything raised to a power requires a chain of the derivative of what's inside the parenthesis or root.
Who's that?
Can you go open that? I don't know why he's here. I guess he's doing it. Oh, he got superlative too.
And you got soccer dad.
Yeah. To find the derivative of a parenthesis or square root raised to a power requires a chain of the derivative of what's inside the parenthesis or square root. So anytime you have parentheses raised to a power, you have to attach what's called the chain. The chain, which is the derivative of what's inside. Okay? So today, I'm going to force you to do it my way. There's a reason for my method. Okay, there's a reason why I'm doing this. You're like, couldn't I just do this easily? Like, for example, this one up here. You would still do 3 times 3, which is what? 9. You would still write this, and you would still drop it down to the 2. But what you would have to put next to it is the derivative of this. And that you're like, okay, that seems really easy. It is, but I need you to do it my way first. It's called the U substitution way. I promise you there's reasons I'm making you do it this way. I'm not just making it to be like, well, why do we have to do your annoying long way? Because I said so. All right, I got 4 problems to do. All of them are going to say find the derivative. All right, so number 1, y equals x squared plus 1 to the 5th, okay? Definitely don't want to multiply that out. No, that would be annoying and foiling, okay? So here's what you're going to do first. This is called a U substitution method. This is how I do it, okay? Whatever's on the inside, you call that U, and you write it out on the side of your paper. U is x squared plus 1. Then you take the derivative of the U. What is the derivative of that? 2x, okay? So keep this right here on the side of your paper. All right, just push it off to the side. We're going to use it in a minute. So step 1 I want you to do, I want you to rewrite with the U. Rewrite your problem with a U. So here's what I mean. Watch what I'm about to do. I'm going to write y equals U to the 5th. Isn't that what I have, right? I substituted, I called this U, so I'm just going to call it U to the 5th. Then I'm going to take the derivative of this right here. As if I don't have this, I'm going to take the derivative of the u stuff. So here's what I had, y prime. What is the derivative of u to the fifth? It's 5u to the fourth, and then you attach next to it what's called the chain that you did up here, u prime.
Is that addition?
So as a
Multiplication.
Oh, multiplication.
Once you do that, you rewrote with the u, you took the derivative, now you replace everything back that you wrote with u. So here's what I mean. So I'm going to have, switching here, I would have 5. Instead of writing u again, I'm going to replace u with this up here, x squared plus 1. So I'm going to write x squared plus 1 to the fourth, right? Isn't that what u is? We just established that before. This is u. We have it over here. I've just replaced it. Then, what am I going to write next to it?
2x.
2x, the u prime. 2x, which was, use a different color here. I haven't even finished yet. Now, some teachers would actually call it done and say you're fine, but here's what I want you to do. This is all I want you to do extra. Take that number in front and multiply it to whatever your derivative is. So what's 5 times 2x? 10x. Keep this as x squared plus 1 to the fourth. Do not FOIL it out. And this is your final answer. And you just did what's called a chain rule. This is a very basic chain rule. Again, you're like, really, do I have to do this whole u thing? Yes, you do. I promise you there's a reason for it. Did anybody not understand the process? Rewrite it with the u, take a derivative, replace all the u's. Rewrite, take a derivative, replace all the u's. So it's really nothing too hard that you haven't seen before. Let's do a second example. Y equals 3x minus 2x squared cubed. Y equals 3x minus 2x squared, the whole quantity cubed. All right, first thing you're going to want to do is establish your u. What's your u? 3x minus 2x squared. Take the derivative right now. 3 minus what? 4x, okay? You are going to rewrite this with u's. So this would be u to what power? U cubed. There's the rewrite. You're going to now take the derivative of the u stuff. So take a derivative, and what would you get? 3u squared, and you're going to attach what's called the chain derivative, u prime. Yes, correct?
Yes.
Now what's my last step?
To replace the u's.
Replace the u's. So I'm going to replace my u's now. Put wherever you see a u, you put what your u was. Wherever you see u prime, you put the derivative part. So you would have 3 times 3x minus 2x squared squared times the 3 minus 4x. Now, all I want you to do, you do not have to FOIL this out. You don't have to do anything. Again, some teachers would actually let you, if you got this far, I'd probably give you almost full credit. I'd take off 1 point. Because all I want you to do is this. 3 times that quantity. Any quantity that's just to a power of 1. So that would be 9 minus 12x, right? Put in parentheses. Put the 3x minus 2x squared squared, and that is your chain derivative. Yes.
My only question is, where did you get the u cubed in the rewrite again?
Where did I get the? Here is my u, right? This is
Raised to the power.
this is my u. That's my u,
Oh,
and I'm
that's-
cubing it.
And then you cube it. Oh, okay.
Yeah, so I'm just rewriting it with a u.
Okay, cool.
That's a great question. All right. Next one, 2 more, and we're done. This is an easy lesson, and the rest of the people are gonna have to watch it.
See, they're all like,
Lose.
Hang around.
Should have hang around. No.
He's like, no.
No, he's like, I care. I care. All right, I want to show you this one. anytime you have a, like they like to put extra parentheses around, y'all, and if it's to a power of 1, which I actually added that there, if it's to a power of 1, you don't have to do a chain rule. This is a quotient, correct? You can just do the quotient as is, and actually I think the quotient's easier, but I'm going to show you it as if we had done the chain rule, because I want to show you that both are equivalent if done correctly. So just to show you, here's me doing it the chain rule, and here's me doing it the quotient rule way. And by the way, you can't do quotient rule and chain rule unless it's a power of 1. Well, actually you can, which we're going to do next class, but it's going to be complicated. So that's why I'm saying you really don't want to do a quotient rule unless it's a power of 1, but we're going to do the chain rule on this one. So to do the chain rule, I actually have to first rewrite this as 3 times x squared plus 1 to the negative 1. Do you all understand where that came from? You all understand I'm just moving it up and then changing elevator pass? Okay. So now on the side of my paper again, I would write what my u is. My u is x squared plus 1. And I would take the derivative of that. What's the derivative of that? 2x, okay? And I would go through my 3 steps, rewrite with a u, derivative it, replace. So rewrite this with a u would be 3u to the negative 1. Do you all agree? Have I taken the derivative? Nope, let's take it now. That's why I'm really particular about when I write y prime. Y prime means I'm taking a derivative right now. What would be the derivative of 3u to the negative 1? Negative 3u to the negative 2 times the chain. Once I take the derivative, replace those u's that you have written over here. Replace those u's. So I would have negative 3. Instead of u, I would have x squared plus 1 to the negative 2 power times the chain, which is 2x. Now let's just talk about this and what this looks like. What's a negative 3 times 2x? Negative 6x. And where does this actually belong? On the bottom, so it'd be negative 6x, which just goes to the top. This goes to the bottom as x squared plus 1, change it to a squared. That is the actual derivative. Now, let me show you it done a way easier because it was a product power of 1. You could have done this the quotient rule way, just to show you. Let's do the quotient rule real quick. Denominator, which would be x squared plus 1, times the derivative of the numerator. What's the derivative of 3? 0. Minus the numerator times the derivative of the denominator. Since it's to a power of 1, it would just be 2x. All over denominator squared. Anything times 0, any quantity, anything, is 0.
That's a lot easier.
Exactly. I got the same answer. Done correctly, you'll get the same answer. See?
We'll be allowed to do the quotient.
I would say if it's to a power of 1, yes.
We're allowed.
But if it was to a power of 2, you can't. You have to do it the chain rule.
Why is that?
Because you are now having some quantity raised to a power that's higher than 1, so you have to take the derivative of what's inside. So yeah. All right, and then one more, and I'm done. Yeah, that was my 3rd question. You are going to find the tangent line to the graph. Y equals the cube root of the quantity x squared plus 4 squared when x equals 2. I'll repeat this for my friends in the back who are blind. Find the tangent line to the graph. Y equals the cube root of the quantity x squared plus 4 squared when x equals 2. So it'll be our last example, and we're finished. What did they not give you to begin with that you don't like right now? Oh, why? Why do they do that to us? Because they're annoying. All right, so Step number 1, you really do need to find that y first. I would say just do that. Plug in your x. So let's see, what would it be? Y equals the cube root of 2 squared plus 4 quantity squared. 2 squared is 4, 4 plus 4 is 8, 8 squared is 64. What's the cube root of 64? Anybody know? 4! All right, so that means the point that I'm concerned about is 2, 4. That is my xy point. You all agree? All I did was plug it in, Okay. Step number 2, since we're finding the tangent line, we need a slope. We have a point, we need a slope. So we need to take the derivative. All right, so first things first, when you see a square root symbol, you need to rewrite it as a fractional power. So this would be to the what power? No, look here.
Oh, 1/3.
2/3.
2/3.
2/3. There's a 2 here, 3 there. Okay. Now we're going to go through the whole chain rule thing again and make sure we understand. Your u is whatever's in the parenthesis, x squared plus 4. You take the derivative right now, just as is. 2x. You rewrite this as y equals u to the 2/3. Whatever was in the parenthesis you called u, keep it to the 2/3. Now take the derivative just like this right here. So what would that be? 2/3 u to the what?
-3rd.
-1/3 times the chain. Okay, replace it with the u. I'm sorry, rewrite it with a u, take a derivative. Now we're going to replace those u's. So you would have 2/3, what was my u? This is why I write it in the corner. X squared plus 4 to the -1/3 times the 2x. Now we got to clean this up, y'all, because I don't like the way this looks. 2/3 times 2x is what?
4/3. 4/3 x.
4x over 3 or 4/3 x. I'm going to call it 4x over 3. Here's why. Where does this go?
Bottom.
To the bottom. So here's what you should have. 4x on top from the 2 and the 2x. A 3 on the bottom, yes. And then this goes to the bottom and becomes 1/3. That is the simplified derivative. That is the algebraic way of doing it. Now, I need to find that derivative value. I actually need to find the m, the value of slope. So what am I going to plug in for x? 2. All right, so let's see what that'll be. 4 times 2 over 3 times 2 squared plus 4 to the 1/3. And I'll help you out with this. This is 8. 2 squared is 4. 4 plus 4 is 8. 8 to the 1/3 means the cube root of 8, which is 2. 2 times 3 is 6. 8/6 is 4/3 is your slope value when x is 2. So now, oh my golly, we're almost done. We have our point. We have our slope. Can you all write this in point slope form right now?
Yeah. Man, this is crazy how it's
Isn't it?
just fancy.
Y minus y1 equals m times x minus x1. And then obviously you can clean that up. Do you all see how smart you are, y'all? Look at this. And really the only thing that's new to what you've been doing is this new chain rule that's really not that hard.
Why do you have to add the U one?
The u prime,
Yeah.
because you have to take the derivative of what's inside. It's called the chain. So you
That
take,
equals the derivative.
that is the derivative. So when we used to have something like this, 5x squared, you were actually taking the derivative of x, which was 1. You would go, oh, 10x, and then you'd go like this, times 1. You just didn't know it. Okay? But now I've changed it to 5 times x squared plus 7 squared. You see what I'm saying? That's why. All right. Here's your homework for tonight. It's actually just 12 problems. That's it. Just 12. I wrote them out here. 9, 10, 11, 12, 14, 18, 22, 26, 30, 36, 42, and 46. Okay? Get that done for me. Y'all missed my lesson. And that's every other even, yeah, I've added 4 too.
Oh, wait. We're gonna do all this homework